We're going to take a look now at something that you are familiar with, and that is graphite. So we're going to use graphite as an example to look at some of the perspectives that we take on chemicals in chemistry. So like we saw with the terms, chemistry is the study of matter. Matter is anything that has mass and takes up space. So for example, if I have my pencil lead, well, it's not really lead, it is graphite. I'm going to put a little piece of that graphite there. You might have this in a mechanical pencil. Just as a little bit of context, graphite we find in our pencils. It's also in lithium batteries, which are in most of our phones and other devices. Comes from the Greek word graphene, which means to write or draw, because obviously this material makes a good writing, drawing material. So throughout the semester with chemistry, I'm going to use this triangle occasionally to help remind us to have three different perspectives on any of the substances that we're talking about. And this extrapolates to life. If you can see something from three different perspectives, you're probably going to understand it better than if you just look at it from one perspective. So the three perspectives we're going to take are macroscopic. Macroscopic is generally going to be like what you can see, touch, feel with your senses. Particle is going to be something that we do in a couple ways. You'll see drawings like this that show the little atoms here. So they give us a sense of what it would look like at a particle level, and we'll also build some models. Black always represents carbon, so we'll have black atoms, for example, to help us think about the particles. And then we'll also use symbols, and this is maybe what you think of most with chemistry is, oh yeah, we write C for carbon, that sort of thing. So macroscopic, kind of what we're seeing, particles, thinking about those little atoms, and then symbols here. And some of you will be better at one thing than another, and that's why we want to have conversations too, so that maybe between the three of you, you're able to contribute, oh, I really get the particles, and oh, I really get the symbols, so let's put our heads together. So let's go through each triangle, and we're gonna write some things, some observations of our graphite here. So our triangle is going to be looking at carbon, and specifically we will be looking at pencil lead, but it's not really lead. We are looking at graphite. So macroscopically, if I were to draw this little piece of graphite, since I won't have it forever, I could draw it like that, and I could write down some observations of that graphite. And I'm just going to, as a connection piece here, say graphite, carbon, graphite. This is all carbon atoms here. So those are all the same thing. So when I observe this, and you want to get better at observing things in chemistry, I might say that this little bit of graphite here is gray. Brittle. Brittle means it breaks easily. I could say that it's a thin rod. I could say that it's solid. When I pick it up, it doesn't feel very heavy, so I might even put a question mark. I don't think it's very dense. It doesn't feel very heavy when I pick it up. I could also measure this. So when we look at the macroscopic, we want to be able to observe it, describe it, measure, and count it. We want to quantify what I've got here. So I could count the number of rods, so one rod, but I could also get a ruler out and I could measure it in inches or centimeters. It's a very small mass, so I could also measure it in, say, milligrams or ounces. So I could take some measurements of that little piece of graphite. So that would be some macroscopic kind of perspectives on that graphite. As I move down to the particles here, a couple things I want to point out to you. So each of these little balls, like I showed you a minute ago, those are each representing a carbon atom. So we have lots of carbon atoms that are all bonded together. So these solid lines are going to be bonds, and these dashed lines, those are going to be attractions between layers of graphite. So what graphite is it's sheets. We have a sheet on top of another sheet, and they slide on each other really well, and you can slide a sheet onto your paper, and now you've written something. So these are individual carbon atoms. And I could say that these are sheets of graphene. I can also measure here. So this PM stands for picometers, and that's telling me the distance between the nuclei of these two atoms. So how close are they to each other? So that's a particle perspective. If I keep going here to a symbolic perspective, now I see that C for carbon again. This is C graphite, not to be confused with C diamond. So I happen to have one of those with me here today. This is also all carbon. It's just put together in a different arrangement than these sheets that we see over here. So I can see here from just that carbon that I only have one element. And this graphite here is telling me what phase that is in. It's not a liquid, it's not a gas, but it's in the graphite, these sheets kind of form. So if we come over here, these are some of the things that we'll be doing throughout the semester also. We'll observe and describe. So we used words and drawings, and we can use those at each corner. We measured or counted. So we saw some units here that we could use to measure, even all the way down to the atomic scale. And in terms of counting, here we can see that this is carbon graphite. There's no numbers, so that tells me I just have one. We infer one. And then I can also connect, and this is what you want to do with your three perspectives, find carbon, and I used the green for the carbon to say here's carbon, carbon in words, carbon in balls and sticks, and then carbon written as a symbol. Last thing we want to look at on this slide is a couple of terms here at the bottom. So physical properties are properties that we can observe or measure without changing a substance's composition. And we have a whole bunch of physical properties that we observed and measured here without having to change the atoms or their arrangement here. Things that you might generically say are physical properties. You might look at length, you might look at mass, the temperature of a substance, the color, the density. Those are all physical properties. A physical change is going to alter a substance without changing its composition or bond. So it's still essentially going to be these carbons connected in this certain way. And a physical change could be something like this. So if I grab my little piece of graphite here and I snap it in half, there's no sparks flying or big explosions or anything. I just broke it into smaller pieces. So a couple of common examples of physical changes are when you break something, or also if you mix it with something. So for example, I could take my bits of graphite here, and a physical change could be that I decide to mix them with my cinnamon salt mixture here. I haven't changed the carbons, right? They're all just kind of sitting next to each other, mixed up, but that mixing would be a physical change. So that gives you three perspectives. We can connect between them, and a couple of words to talk about the physical properties we saw of carbon in the form of graphite here.